Hello and welcome to the 14th episode of Simply Electronics Basics. In today's video, we're going to have a look at one aspect of multimeters, measuring resistance and continuity. I'm sure you're all aware of what resistance is, but we're going to show you how to actually measure resistance with a multimeter, and we will also have a look into what continuity actually is. I'm going to split these videos into a few separate videos as I don't want to overcomplicate for any new electronics enthusiasts. So let's go ahead and get straight into it. In front of me here, I have a digital multimeter. Multimeters are called multimeters because they pretty much do exactly what they say on the tin. This is a fairly standard and basic multimeter to keep things simple, but there are more advanced multimeters that can measure and do many more things. On pretty much all multimeters, to measure resistance, you need to turn the dial towards the ohm symbol. This is to measure resistance. I have another multimeter which is very similar, but instead allows me to select a range of resistances. If I know I want to measure resistances above 20 mega ohms, I would turn the dial to this. Or if I'm looking for lower resistances, for example under 2 kilo ohms or even under 200 ohms, or to measure continuity, I would select the lowest value. However, this multimeter will automatically select the range for me. So if I measure a certain resistance, it will change its display to show the result accurately. With any multimeter, you get two test leads. This one already has test leads built in, but with this bigger multimeter, you can see I have many different ports. Don't worry about these ones for now. These will come up in later videos. The black lead always goes into the COM port, and the red lead will go into one of these. For measuring resistance, use this port for measuring volts and resistance. When you want to measure resistance, for example the resistance of a wire or a certain component, such as this resistor, you can simply take the two probes and make sure you get a good connection across the component by ensuring the metal on the end of the probes are touching the metal on either end of the component that you're testing. You can see here that my multimeter has recognized that I am measuring the resistance of this resistor and has given me a result of approximately 15 ohms. Here's a closer look of the probes contacting the ends of the resistor. When we talk about measuring continuity, we are talking about measuring very low resistance, which enables us to ensure that we have a good connection in a circuit. Across this wire, it should show very low resistance. As you can see, the resistance of this wire is less than half an ohm, a very good connection across this entire wire. This means that I have good continuity. Now let's just say something bad were to happen to our cable. The cable seems to have suffered a slight break in the middle of it, but it's not completely broken. How can we test if this cable will still work? Well, we can do this simply by measuring continuity with a multimeter. If I now put the probes across this wire, you can see the multimeter is just showing 0L. 0L on any multimeter means no continuity, and therefore there is no connection between the two probes. So in this case, this wire is absolutely useless. It is now broken. There's no continuity, so we might as well throw this wire in the bin. You can see that if I actually connect the two probes together, the multimeter is showing zeros all around, meaning there is an excellent connection between these two probes. So hopefully you enjoyed this video and learned something from it. Make sure you subscribe for more interesting videos, leave your comments below, and give this video a thumbs up if you found it useful.